last video, we were wondering what was going to happen to the average cost, or excuse me, not to the average cost, but to the cost to clean up this spill if we look beyond 100%. Well, of course, we know that it doesn't really make sense to look beyond 100%, but we just wanted to kind of see, mathematically maybe what that graph would look like. So let's say we go from 0 to 200, and again, 200 doesn't make sense in this context because we can't really clean up more than 100%. And then I'm going to just kind of change my y min to -2, just in case, it does actually show up down here. So let me go ahead and graph that. So there it goes up to 100%, and yet lo and behold, there the values are negative, and so after this point, this asymptote sometimes differentiates values that do make sense from values that don't make sense. So anything less than 100% does make sense. Those will produce positive costs that grow bigger and bigger as the percentage, as x goes to 100, but as x passes 100, the costs diverge infinitely away. And again, you kind of notice this effect of this vertical asymptote. The curve kind of hugs or gets very close to the vertical line, x equals 100, and similarly here, kind of the y values go down to -infinity as x approaches 100 from the right-hand side. So coming from the right to the left, you rode this curve. As you got closer to an x value of 100, you would go down towards -infinity. Okay, we are next going to take a look at a modeling problem because sometimes whenever we discuss functions like the rational function, the discussion can be a little bit forced because it just seems like we're doing more mathematical analysis of functions than we are of how it really applies. So let's take a look at an instance where a model that we'll build will actually be rational based on the nature of what we want to study. So in order to run an event, a campus club must rent out a campus room on a weekend, which will run them 125 bucks. Each person will cost them $4.25 in terms of food and beverage. And suppose we want to look at average cost per person. Okay. Well, first of all, let's just kind of look at a couple of instances. So what does the average cost per person depend on? Well, it depends on the number of people, and then it also depends on the total cost, because the average is going to be the total cost divided by the number of people. And we'll kind of look at this a little bit more detail here, so it makes a little bit more sense. But let's just say that only one person attends, the person who is essentially running the event. Everybody ditches out on it, but only one person attends. Well, in order for that person to attend, it's going to cost them $125, the club, right? Because they have to rent out the room, and electricity and facilities has to be there, and people to set up and whatnot. And it's going to cost $4.25 for just that one person. So in total, this event is going to cost $129.25. Okay, so that means that on average, $129.25 divided by there only being one person, well, for the per person cost is, well, this is in dollars, and this is the number of people. So my end up resulting units would be $129.95 per one person. Dollars per one person. Well, that's a very, very high cost, right? To allow that one person to attend, that is going to be very, very expensive. Well, as you probably know, we're going to kind of build up this logic and say, well, suppose that 10 people attend. Well, that's going to be the 125 bucks, plus it's going to be the $4.25, but that's applied for 10 people now, so I have to multiply that by 10. Well, 125 plus $42.50, which would be the total cost for all the people to attend, would be $167.50. So $167.50. Now, if I divide that, if I take $167.50 as my total cost, and that's divided among, now not each person is not going to pay this much, this is just how much it costs to have that many people in attendance. This is for 10 people, so it actually averages out to $16.75. Well, that's much cheaper per one person. Or maybe they're trying to figure out what they need to charge in order to break even. Well, if only one person attends, they can't charge that person $129.95, but that's what they would need to charge in order for them to break even. Now notice we're not talking about average rate of change here. We're talking about the average cost. So it's literally take the total cost, divide by the number of people. So $167.50 among 10 people splits up that cost to $16.75 per person. Well, let's kind of make this a little bit more general now. So we have, let's say, we'll just call it X people. The total cost of having those X people attend is the $125 overhead plus $4.25 times X, right? Times the number of people. And to find the average, we take the total cost, which is 125 plus 425X, and then we take that result and we divide by the number of people. And so therein lies our formula. So our our average cost, let's call that A, is equal to 125 plus 4.25x divided by x. So let's provide more of an analysis of this. So questions we might want to ask. Let's suppose that x equals, you expect about 100 people to attend. So if that, you can expect that number to be true, we can figure out pretty easily what the cost is going to be. And I'm going to put this into my y equals screen. 125 plus 425x divided by x. So make sure your numerator is in parentheses. And if your denominator has anything more than just a single value or variable, make sure you also put that in parentheses. And so I'm going to set my table here to start at 0 people. And maybe I'll look at, I don't know, maybe 10% increments. So I'm going to go over my table, and first thing I notice is that if 0 people attend, then I get an error. Well, why would I get an error? Why would that make practical sense, or does it, to have an error average cost, right? Y here represents the average cost if 0 people attend. Well, one way to think about that is if 0 people attend, then there's nobody to soak up the total cost, right? So it doesn't really, it's impossible, or it's undefined for 0 people to attend. There is no average cost. There's nobody there to soak up any of that cost whatsoever. But as we go up, we notice that the cost per person drops pretty dramatically at first, right? It goes from $16.75 to $10.50 if you increase by 10 people. But then if you go from 50 to 60 people, we notice that that cost per person doesn't go down by quite as much. So 100 people is going to result in an average cost of $5.50. Okay, so when, and remember our ordered pairs look like this, x comma a. So this is people, and this is average dollars per person. And so we know that when there are 100 people, each person would end up paying about $5.50 in order for them to break even. So in order for them to not walk out deficient. So maybe they want to mark it up and they want to say, well, we're going to charge $7 so that we make sure that we can get some funding or a fundraiser for our club. All right, and as we go up and up and up and we want to kind of understand what's happening to the average cost. And we notice that quickly that average cost seems to be slowing down. So what is it slowing down to? We notice that, you know, normally in a lot of our functions, the average, or the value of y seems to be approaching 0. However, let me sort of just change the table, change in table value. Let me make this 100 people and see what happens, just so I can kind of look more rapidly to see what's taking place. So if I increase by 100 people at a time, now this is obviously a lot of people, but I'm starting to notice that my average cost is really slowing down at around 4.2 something. Now, in a previous video, we mentioned that there seems to be a correlation here, that there seems to be a correlation between the coefficient of x, which is 425, and something with respect to this being a 1x down here. And in fact, 425 divided by 1 is equal to $4.25. So let me kind of graph this and say, I'm going to look at from 0 to maybe, I'm going to go to 3,000 people, just to really see what happens in the long run. And my cost, well, I noticed that the costs seem to kind of converge towards $4.25 per person, but I noticed that I had costs as high as about $17, and so I'm going to graph that and see what it looks like. And there it is. Initially the cost is very high. All right, if I really kind of zoomed in here, this is an asymptote, that x equals 0 is undefined, so I'm going to get this kind of behavior. But I also notice that now my asymptote doesn't appear to be 0 anymore. It appears to be along this line here. And if I just trace it and kind of follow it to just get a good, get a good kind of image of what's happening there, I can kind of see what my table was telling me, that as I get more and more and more and more people, my cost seems to be going down towards 425. And maybe let's change our table increase to 1,000 people at a time, just so could we be more confident that this is going towards about 425. Well, there you go. We're going 1,000 people at a time, and you notice that it's really, really, really slowing down to about $4.25. And in fact, we would say that our vertical asymptote is A equals $4.25. So let me put this on the next page. So here's our average cost, and here's our number of people, and my asymptote horizontally, it appears that no matter how many people I invite, my average cost never seems to be dipping below $4.25. So it kind of looks like this. And this is A equals 425. And I also noticed that in my denominator, because I'm dividing by x, we kind of already mentioned this, that x equals 0 is also an asymptote, and that's a vertical asymptote that goes up and down, and a horizontal asymptote goes left and right. So how would I interpret this? How would I be able to talk about this? Well, again, first of all, we notice that average cost seems to be approaching 425. So let's take a look at a better look at this function. I'm going to write this function down over here. And the way I'm going to have this written down is 4.25x plus 100. And down here I'm going to write 1x plus 0. And why am I doing that? Just to get you to see that these are both linear functions. These are both linear functions. And so, again, this is a rational function by definition. It's a ratio of two polynomials, which both happen to be linear. And one of the most notable things here is that regardless of how many people you invite, the cost never seems to be dipping down below $4.25. Well, why might that be? Oh, this is 125, excuse me. Well, think about it this way. If there's this $125 is fixed, right? So as x gradually gets larger and larger and larger, and more and more and more people attend, well, this $125 sort of gets distributed among all those people. So if you have 125 people attending, then that $125 kind of gets evenly distributed. $1 of this cost is soaked up by each of the people attending. So in that case, if you had 125 people attend, your cost should only be about $5.25. Let's just verify that. So in our table, we'll just start at 125 people, and we should see that if 125 people show up, then each person is going to have to soak up $1 of this overhead, and they're going to have to each of them is going to cost $4.25 to show up. So each of them should be charged a minimum of $5.25, because that's the average cost per person. The cost gets distributed evenly among the people. Well, as you begin to invite more and more people, now that $125 gets absorbed among each person. So they're paying the $4.25, but they soak up a very, very, very tiny portion of this. So their average cost, you know, like this extra stuff that you see here, this extra penny, well, if 12,125 people were to attend, then each person would only need to soak up just a little over a penny of this $125 in order for that cost to be soaked. So we could say that, let's put it this way. So the horizontal asymptote interpretation, we'd say as a lot of people, and I'll just kind of say a lot in quotes, a lot of people show up, or more and more people show up, the cost per person gets closer and closer to $4.25. Okay, now let's do the vertical asymptote. So vertical asymptote, we notice that as you kind of have to think about going in this direction. If you climb this direction along this curve, so as we decrease the number of people, the cost per person gets very, very high, right? If only one person shows up, as we saw earlier, then that one person soaks up all of that $125. And of course, it doesn't make sense to talk about less than one person, but in theory, if you can invite less than one person, then your cost would be even higher because you'd be dividing by something less than 1.